Okay, today we're looking at isosceles and equilateral triangle. So I want you to write out the theorem. The theorem for isosceles triangle, and I'm going to abbreviate it, is if two sides in a triangle are congruent, then we know the opposite angles are also congruent. It's quite a bit abbreviated. In a triangle, if two sides are congruent, then I know the opposite sides are congruent. Knowing the figure is very, very important because not every figure is drawn in a specific orientation. So here's what I want you to do. Take your figure, rotate it 90 degrees, counterclockwise. And then I want you to put this angle right here is called the vertex angle. And we know the base angles are congruent since we have an isosceles triangle. So let's point at it. We have base angles. And then we have the base is the length of the base. Any idea what we're going to call the two congruent sides? These two right here? They're called something. They're same side. They're legs. So the two equivalent sides in an isosceles triangle is called a leg. Okay, so know how to draw this if I tell you vertex is somewhere, okay? So given that, let's move on to an example. Sam, let's read example number 1, please.
Okay. Use the diagram to find x. If angle ABC is isosceles with vertex angle A and angle A equals 130.
So we have isosceles with the vertex angle A. This is very important. Go to angle A and write out the word vertex. And then you're going to write out, well, given that vertex, we know these two angles are congruent. Opposite of the vertex is the side base. And let's fill in the information I know. It says angle A is 130. Here is 130. Could I give the same variable x on angle B as well? Since we have an isosceles triangle?
Yes.
So algebraically, it is 130 plus 2x must be 180, which gives us 2x. How many is 180 minus 130? 50. So x must be how many? 25. And it says to find the x. We're good to go. So if I tell you we have an isosceles triangle, vertex does not go anywhere. It has to be specific. So moving on to example number 2. Look at my notation. If my notation says these two are congruent to, what can I say about the vertex? Where is my vertex? It's to the right. Then I know the given expression are called the what kind of angle? The base angles, so we know they are congruent to. So do I add them up and equal to something or equate it to each other? Equated. 7x plus 35 must be x plus 65. Okay, go ahead and solve for x. Should get some clean number. What is your clean number?
5.
I agree. Okay, number 3 is quite redundant, so we're going to move on to the next page. So just know where the base angles are and where the vertex will be, and you'll be good to go. We're going to skip that proof. We need that after 4.7. Is it 4.7? Yeah. Okay, we're looking at number 5 next. Okay, what kind of triangle do I have here? Equilateral. Now I'm going to give something away. Y'all ready?
Yes.
I want you to give me 2 bullet points. And of course, put a big fat star on this one. And let's write out something. Equilateral triangle is blank an isosceles triangle. And let's write the converse of that. Isosceles triangle is blank an equilateral triangle. Did I repeat something wrong? We're good? Okay. So let's kind of look at the general rule that we talked about back in Unit 1. So in case you forgot Unit 1, listen carefully. If I state the more specific first, the answer is always. Okay? If I state the less specific first, it's going to be typically sometimes. So in this case, Is the equilateral more specific or isosceles more specific? Equilateral. So equilateral triangle is always an isosceles triangle, meaning an isosceles triangle is sometimes an equilateral triangle. Remember this. Okay? So given that, let's look at example number 5. What triangle do I have specifically? Equilateral. So we know all the angles are also congruent to. Do we also know what the angles must be specific to for each? Has to be 60, because if I have 60, 60, 60 must be 180, right? Now, since I know 3x minus 18 is the expression that is taken in place of 60 degrees, set them equal to each other. Now, if you forget this, can you choose to write that 3 times and equate it to 180?
Yes.
For sure. So we have 3x is equal to 78. Then x must be at least 20 something. 26 it is. Very good. Boom. Is everyone good with that?
Yeah.
Okay. Let's try example 6 with a neighbor. Same idea. Because of this, help each other.
What did y'all get? And
Now, are we only looking for the x though?
no.
Specifying xy. So when you plug in the 10 into the expression given on xy, we should get how many? 46.